Okay, hello the grade 11s. What we're going to be looking at today is essentially all the factoring you did back in grade 10. One quick crash course that's going to just cover everything you did in about 2 weeks last year in grade 10. So a lot of stuff from last year is going to come back at you all at once, and we'll see how much you remember. Factoring, as we told you last year, is probably one of the most important skills coming out of grade 10, and we're going to be using it a lot this year. Those of you going on to advanced functions and beyond, will be using it there a lot too. So really, really important skill. So when you're looking to factor something, and remember when you're factoring, you're going to have everything written in standard form first. The first thing you should always look for, just to make our lives easier and to get us further along a step to having something fully factored, is to look for that common factor first. Anything you can take out of every single term, it should be done first. And that includes factors of -1. You'll see an example coming up how it can make it a little bit easier to try and work with. Once you've done that, the kind of factoring that you saw last year went into a few different categories. The one that you saw most often was looking at trinomials. So within trinomials, you had a few different ones. You had simple trinomials, where the a value happened to be 1. You had complex ones where the a value was not 1. They tend to be a little bit trickier to work with, especially working with the arrays. And you had ones that were called perfect square trinomials. So if you happen to have the first term and last term being perfect squares, and it turned out to be plus or minus 2ab in the middle, you factor into a perfect square. So we'll look at examples like that coming up. You did examples of grouping. Grouping tended to come up. It was handy when you had 4 or more terms. It was something that we could try. If you had 4 or more terms, there's no common factors you could work with. And the last thing you looked at was difference of squares. So you had a perfect square minus a perfect square. It had a certain pattern to it, and you could factor it as so. So a squared minus b squared to factor into a minus b, a plus b. And we'll see some examples of that too. You'll see some examples of everything coming up. So a lot for you to look forward to over the next 15 to 30 minutes. So going ahead, first thing we're going to do is factor each of these and think about what kind of factoring we had, whether it was common factoring, difference of squares, so on and so forth. So looking at this one here, 16x squared minus 2x. Number one thing you always look for is a common factor. So if you look at these two terms between 16x squared and 2x, both of these have a 2 in them, and both of these have an x. So we're going to take out that 2x as a common factor. We're going to see what's left behind. So from the 16x squared, when we take out the 2x times what gives me 16x squared? Well, 2 times 8 gives me 16. X times x gives me x squared. And from this 2x, we factor it out. It's not a 0 that's left, because remember, when we multiply things through, we should get what we started with. So 2x times what gives me minus 2x? Well, it's 2x times minus 1. So this factors into 2x times 8x minus 1. This can't factor any further, so the only thing that we have here is common factoring. Okay, it's nothing too exciting there. Okay, take a look at the next one. X squared minus 3x minus 28. This is what we call the simple trinomial. So trinomial being 3 terms, simple because your a value there was equal to 1. Okay, and there are 2 ways you could look at factoring a simple trinomial. So the way most of you did last year, if you were at our school, is using an array. So in this case, what you did is you took your squared term and you put it in the top left of your array. You took minus 28, put it in the bottom, and then we worked out what would have to go on the outside to multiply to get us x squared minus 3x minus 28. So if you're looking at x squared, the only thing that multiplies to give you x squared would be x and x. And then we get to figure out, okay, there's a few different options for things that can multiply -28. You can have -28 and 1, 2 and -14, positive 14, -2, and so on and so forth. But remember that when we multiply these through, we're going to be multiplying them by x. So our terms here along the diagonal have to add to our middle term here in the original expression. So whatever's here has to add to give us -3x. Whatever's on the outside here has to multiply to give us -28. So looking for two numbers that are going to multiply to -28, but when added together here in the middle, give us -3x. So those two numbers are going to be -7 and +4. Because when you fill in the rest of the array, you get 4x here, minus 7x here. So when you put those together, you're going to get -3x. So this factors into using the outside of the array, x minus 7 and x plus 4. Okay, some of you may have simply just looked at simple trinomials as factoring as, okay, I need two numbers that multiply to negative 28 and add to negative 3. And once you find those two numbers being negative 7 and 4, you could go straight from there to your final factored form. So two ways of going about it. Both are valid, so whatever works best for you. Okay, and again, that one's called a simple trinomial because the coefficient of the x squared here happens to be 1. Okay, a couple more worth looking at here. So this one right here, 169x squared minus 49. Only two terms in this one. One thing you might notice here is if you look at 169x squared, that's a perfect square because 13x times 13x would multiply to this. 49 is a perfect square. So if you look back here, this sort of follows that difference of squares. We have two perfect squares that are being subtracted. That's going to factor into a minus b, a plus b. So what this is going to wind up being here, a nice quick way to factor this one, is, okay, so 13x times 13x would give me 169x squared, and 7 times 7 gives me 49, so we're going to have 13x minus 7 and 13x plus 7. Okay, and this is factored, and I'm done. Now, if you recognize the difference of squares pattern, you can get to this answer pretty darn quickly. If you don't, however, it doesn't mean that there's no way of solving it. You can always throw things into an array. So you could throw in 169x squared up here, okay, and minus 49 down here. And again, you'd be thinking, okay, what multiplies 169x squared? There's not tons of options. What multiplies to 49? Not tons of options there as well. And the thing to watch out for here is, again, when you have these terms that you're going to wind up with in here, they would have to actually add to 0 because there's no x term in here. So you would try 13x and 13x here, and positive 7 and negative 7 there. Because when you fill in the rest of the array, 13 times 7 gives you 91. So you'd have negative 91x here and positive 91x here. So those would cancel out when you put them together to get 0x, and you'd wind up with the same answer. So again, recognizing the difference of squares pattern makes it easier, but if you don't, you can still factor it using an array. Okay, last one over here. Give it a try on your own first, and then when you're ready to see the answer, just push play again. So you'll notice here you have two things being subtracted as we did here. However, you'll notice that they're not both perfect squares. 27 is not a perfect square and 48 isn't either. One thing you always have to remember though, first thing you should always look for when you're factoring is to see if there's a common factor first. And if you look between 27 and 48, both of those are divisible by 3. So we're going to factor out a 3 from this one, and that's going to leave me with 9 minus 16 x to the 14, which looks slightly better, not super better, but slightly better. The nice thing though now is when you look at it, what's left over here, this 9 and this 16x to the 14, are both perfect squares. So we have a perfect square minus a perfect square. It becomes a difference of squares pattern just like we saw over here in C. So I'm going to keep my 3, and now 3 times 3 gives me 9, so I'm going to have 3 minus 4, and then to get x to the 14, that would be x to the 7 times x to the 7, so I have 3 minus 4x to the 7, and then following the rest of the pattern, 3 plus 4x to the 7. Okay, again, recognize that difference of squares pattern makes this one a lot easier. Okay, hopefully that got our brain back in gear a little bit when it came to factoring. Let's take a look. There's a whole bunch of other examples here. I would like you to take a minute, try them on your own, just see what comes back to us. Again, so pause it, take a few minutes, work through these, and push play when you're ready to go through them. Okay, so if you take a look at this first one here, it's a complex trinomial. Okay, you have an a value that's not 1, it's 16 in this case. There's no common factors here. One thing that might stand out to you, if you look at the first term and the last term, they're both perfect squares. Okay, so keeping that in mind, this might be worth checking to see if it's going to be a perfect square trinomial. So if you're going to set up your array with 16x squared and 25, let's see if it is going to be a perfect square trinomial. So if it is, we're going to have 4x and 4x here, and here we're going to have 5 and 5, or negative 5 and negative 5. Now, which one could it be? Well, if it's going to have to add to a positive here in the middle, it can't be negative 5 and negative 5, so this will be plus 5 and plus 5. So let's see what happens here. We get 20x and 20x, and those together are going to add to 40x, which is what we want. So this is a perfect square trinomial. This is going to factor into 4x plus 5 all squared. Okay, moving down to this one. First thing you want to check for, as always, is if there's a common factor. This would be a pretty complex one to try without looking for a common factor. One thing you can take out of this is 2. I don't think anything bigger comes out of there. So if we take out a 2, we're going to be left with 16x squared minus 56x plus 49. Once again, I mean, it makes what's left over a little bit nicer. You might notice again that we have a perfect square here and a perfect square here. So again, let's try it in our array, see if it works out. So doing so, I'm going to have 4x and 4x. For 49, again, 7 and 7 are negative 7 and negative 7. Here we have to add to a negative though, so it means it's going to have to be negative 7 and negative 7. So I get negative 28x in both of these parts of the array right here, and those will add to negative 56x, so it does work, which is that's what we have here. So we're going to have 2 and then 4x minus 7 all squared. Okay, last but not least for this one over here, you may want to rewrite this one just so it's in standard form, descending order of power. So you'll have negative x squared plus 8x plus 20. And one thing I strongly suggest that we do to make our life a little bit easier is remember, well, it doesn't look like there might be a common factor here. You always want to try and factor out a leading negative 1 whenever you can. If you're working with arrays, or even if you're not working with arrays, it just makes it a lot easier to work with, because then you can make this a simple trinomial that's left over. It'll have 1 there instead of a negative 1. So we're taking out that factor of negative 1, and what we're going to be left with here is x squared minus 8x minus 20. Okay, it changes the signs of everything else that's there. And again, what that does is it makes this a lot easier to work with, because you don't have a negative as a leading term. So if you're looking at this, it's a simple trinomial now. So you're looking at two numbers that are going to multiply to negative 20 and add to negative 8. Or if you want to use an array, we're going to have x and x here. And again, what multiplies to negative 20 adds to negative 8? Well, you're going to have negative 10 and 2. So that'll give me 2x and negative 10x, which adds to negative 8x. So what this is going to factor into, I still keep my negative hanging around. I'm going to have x minus 10 and then x plus 2. Okay, so it's not too bad once you have it simplified, once you've taken out that negative. So just do keep that in mind that, you know, negative 1 can be considered a common factor, and it's a lot easier to factor if the leading coefficient happens to be 1. And just keep that in mind. Alright, about running out of time here, so I'm just going to pause it right here and continue this in the next video.